Ensuring students master their basic facts remains a shared goal among parents and educators. That said, many educators wonder what should replace the memorization drills that cause so much harm to their students' math identities. Today on the podcast, Jenny Bay Williams talks about how to meet that goal and shares a set of productive practices that also support student reasoning and sense-making. Welcome to the podcast, Jenny. We are excited to have you.
Well, thank you for inviting me. I'm thrilled to be here and excited to be talking about basic facts.
Awesome. Let's jump in. So your recommendations start with an emphasis on reasoning. I wonder if we could start by just having you talk about the why behind your recommendation and a little bit about what an emphasis on reasoning looks like in an elementary classroom when you're thinking about basic facts.
All right. Well, I'm going to start with a little bit of a snarky response that the non-reasoning approach doesn't work. Okay. So one reason to move to reasoning is that memorization doesn't work. Drill doesn't work for most people. But the reason to focus on reasoning with basic facts beyond that fact is that the reasoning strategies grow to strategies that can be used beyond basic facts. So if you take something like the making 10 idea, that 9 plus 6, you can move one over and you have 10 plus 5, is a beautiful strategy for 99 plus 35. So you teach the reasoning up front from the beginning, and it sets students up for success later on.
That absolutely makes sense. So you talk about the difference between telling a strategy and explicit instruction. And I raise this because I suspect that some people might struggle to think about how those are different. Could you describe what explicit instruction looks like and maybe share an example with listeners?
Absolutely. First of all, I like to use the whole phrase explicit strategy instruction. So what you're trying to do is have that strategy be explicit, noticeable, visible. So for example, if you're going to do the making 10 strategy we just talked about, you might have 2 10 frames. One of them is filled with 9 counters and one of them is filled with 6 counters. And students can see that moving one counter over is the same quantity. So they're seeing this flexibility that you can move numbers around and you end up with the same sum. So you're just making that idea explicit and then helping them generalize. You change the problems up and then they come back and they're like, oh, hey, we can always move some over to make a 10 or a 20 or a 30 or whatever you're working on. And so I feel like in using the counters, or they could be stacking unifix cubes or things like that, that's the explicit instruction. It's concrete. And then if you need to be even more explicit, you ask students in the end to summarize the pattern that they noticed across the 3 or 4 problems that they solved. Oh, that you take the bigger number and then you go ahead and complete a 10 to make it easier to add. And then that's how you're really bringing those ideas out into the community to talk about. For multiplication, I'm just going to contrast. Let's say we're doing add a group strategy with multiplication. If you were going to do direct instruction and you're doing 6 times 8, you might say, all right, so when you see a 6, then a direct instruction would be like, take that first number and just assume it's a 5. So then 5 eighths is how much? Write that down. That's direct instruction. You're like, here, do this step, here, do this step, here, do this step. The explicit strategy instruction would have, for example, like I like for 8 boxes of crayons because they oftentimes come in 8s, so but they'd have 5 boxes of crayons and then one more box of crayons. So they could see you've got 5 boxes of crayons. They know that fact is 40. If they're working on their 6s, they should know their 5s. And so then what would one more group be about? So just helping them see that with multiplication through visuals, you're adding on one group, not one more, but one group. So they see that through the visuals that they're doing or through arrays or things like that. So it's about them seeing the number of relationships and not being told what the steps are.
And it strikes me too, Jenny, that the role of the teacher in those 2 scenarios is pretty different.
Very different, because the teacher is working very hard with the explicit strategy instruction to have the visuals that really highlight the strategy. Maybe it's the colors of the dots or the exact 10 frames they've picked and have they filled them, or whether they choose to use the unifix cubes and how they're going to color them and things like that. So they're doing a lot of thinking to make that pattern noticeable, visible, as opposed to just saying, do this first, do that second, do that third.
I love the way that you said that. You're doing a lot of thinking and work as a teacher to make a pattern noticeable. That's powerful, and it really is a stark contrast to, let me just tell you what to do. I'd love to shift a little bit and ask you about another piece of your work. So you advocate for teaching facts in an order that stresses relationships rather than simply teaching them in order. I'm wondering if you can tell me a little bit more about how relationships-based instruction has an impact on student thinking.
So we want every student to enact the reasoning strategies. So I'm going to go back to addition, for example, and I'm going to switch over to the strategy that I call pretend to 10, also called use 10 or compensation. But if you're going to set them up for using that strategy, there's a lot of steps to think through. So if you're doing 9 plus 5, then in the pretend to 10 strategy, you just pretend that 9 is a 10. So now you've got 10 plus 5, and then you've got to compensate in the end. You got to fix your answer because it's 1 too much. And so you've got to come back 1. That's some thinking. Those are some steps. So what you want is to have the students automatic with certain things so that they're set up for that task. So for that strategy, they need to be able to add a number onto 10 without much thought. Otherwise, the strategy is not useful. The strategy is useful when they already know 10 plus 5. So you teach them that relationship, 10 and some more, and then they know that 9's 1 less than 10. That relationship is hugely important, knowing 9 is 1 less than 10. And so then they know their answer has to be 1 less. 9's 1 less than 10. So 9 plus a number is 1 less than 10 plus the number. Huge idea. And there's been a lot of research done in kindergarten on students understanding things like 7's 1 more than 6, 7's 1 less than 8. And there are predictive studies looking at student achievement in first grade, second grade, third grade. And students, it turns out that one of the biggest predictors of success is students understanding those number relationships. That 1 more, 1 less, 2 more, 2 less, hugely important in doing the number sense. So that's what the relationship piece is sequencing facts so that what is going to be needed for the next thing they're going to do, the thinking that's going to be needed is there for them, and then build on those relationships to learn the next strategy.
I mean, it strikes me that there's a little bit of a twofer in that one. The first is this idea that what you're doing is purposely setting up a future idea, right? It's kind of like saying, I'm going to build this prior knowledge about 10ness, and then I'm going to have kids think about the relationship between 10 and 9. So like the care in this work is actually really understanding those relationships and how you're going to leverage them. The other thing that really jumps out from what you said, this has long-term implications for students' thinking. It's not just fact acquisition, it's what you said. Research shows that this has implications for how kids are thinking further down the road. Am I understanding that right?
That's absolutely correct. So just that strategy alone, let's say they're adding 29 plus 39. And they're like, oh, hey, both of those numbers are right next to the next benchmark. So instead of 29 plus 39, I'm going to add 30 plus 40, 70. And I went up 2. So I'm going to come back down 2. And I know that 2 less, then a benchmark's going to land on an 8. So that, again, it's coming back to this relationship of how far apart numbers are, what's right there within a set of 10 helps then to generalize within tens or within hundreds. And by the way, how about fractions?
Talk about that.
It generalizes to fractions. So let's take that same idea of adding, let's just say it's like 2 and 7/8 plus 2 and 7/8. So if we just pretended those were both 3s because they're both super close to 3, then you'd have 6. And then you added on 2/8 too much. So you come back 2/8 or a fourth, and you have your answer. You don't have to do the regrouping with fractions and all the mess that really gets bogged down. And it's a much more efficient method that, again, you set students up for when they understand these number relationships. When you get into fractions, you're thinking about like, how close are you to the next whole number, maybe instead of to the next tens number.
It strikes me that if you have a group of teachers who have a common understanding of this approach to facts, and everyone's kind of playing the long game and thinking about how what they're doing is going to support what's next, it just creates a system that's much more intentional in helping kids not only acquire the facts, but build a set of ways of thinking.
Mike, that's exactly it. I mean, here we are trying to make up for lost time. We never have enough time in the classroom. We want an efficient way to make sure our kids get the most learning in. And so to me, that is about investing early in the fact strategies, because then actually when you get up to those other things that you're adding or subtracting or multiplying or whatever you're doing, you benefit from the fact that you took time early to learn those strategies, because those strategies are now very useful for all this other math that you're doing. And then students are more successful in making good choices about how they're going to solve those problems that are oftentimes, especially when I like to mention fractions and decimals at least once in a basic facts talk, because we get back, by the time we get into fractions and decimals, we're back to just sometimes only showing one way, the sort of standard algorithm way, when in fact, those basic fact strategies absolutely apply to almost always more efficient strategies for working with fractions and decimals.
I want to shift a little bit. One of the things that was really helpful for me in growing my understanding is the way that you talk about a set of facts that you would describe as foundational facts and another set of facts that you would describe as derived facts. And I'm wondering if you can unpack what those two subsets are and how they're related to one another.
Yeah. So the foundational facts are ones where automaticity is needed in order to enact a strategy. So to me, the foundational fact strategies are their names, like the doubling strategy or double and double again, some people call it, or add a group for multiplication, and the addition ones of making tens and pretend to 10 strategies. And in those strategies, you can solve lots of different facts. But there's too much going on in your brain if you don't have automaticity with the facts you need. So for example, if you have your 6 facts and you're trying to get your 6 facts down and you already know your 5s, like automaticity with your 5s, then that becomes a useful way to get your 6s. So if you have 6 times 8 and you know 5 times 8 is 40, then you're like, okay, I got one more 8, 48. That's an add a group strategy. But if you're not automatic with your 5s, this is how this sounds when you're interviewing a child. They're going to use add a group strategy, but they don't know their 5s. So then they're like, let's see, 5 times 8 is 5, 10, 15, 20, 25, 30, 40. Now, what was I doing? Like they can't finish it because they were skip counting with their 5s. They lose track of what they're doing, is my point. So the key is that they just know those facts that they need in order to use a strategy. And that, going back to like the pretend to 10, they got to know 10 and some more facts to be successful. They have to know 9's one less than 10 to be successful. So that's the idea, is if they reach automaticity with the foundational fact sets, then their brain is freed up to go through those reasoning strategies.
That totally makes sense. I want to shift a little bit now. One of the things that I really appreciated about the article was that you made what I think is a very strong, unambiguous case for ending many of the past practices used for fact acquisition, worksheets and time tests in particular. This can be a tough sell because this is often what is associated with elementary mathematics, and families kind of expect this kind of practice. How would you help an educator explain the shift away from these practices to folks who are out in the larger community? What is it that we might help say to folks to help them understand this shift?
That's a great question. And the real answer is it depends, again, on audience. So who's your audience? Even if the audience is parents, what do those parents prioritize and want for their children? So I feel like there's lots of reasons to do it, but to really speak to what matters to them. So I'm going to give a very generic answer here, but for everyone, they want their child to be successful. So I feel that that opportunity to give a problem like 29 plus 29 and ask how parents might add that problem. And if they think 30 plus 30 and subtract 2 to get to the answer, whatever, then that gives this case to say, well, this is how we're going to work on basic facts. We're building up so that your child is ready to use these strategies. We're going to start right with the basic facts, learning these strategies. These really matter. And the example I gave could be whatever fits with the level of their kid. So it could be like 302 minus 299. It's a classic one where you don't want your child to implement an algorithm there. You want them to notice those numbers are 3 apart. And so there's this work that begins early. So I think that's part of it. I think another part of it is helping people just reflect on their own learning experiences. What were your learning experiences with basic facts? And even if they liked the speed drills, they oftentimes recognize that it was not well liked by most people. And also, then they really didn't learn strategies. So I feel like we have to be showing that we're not taking something away, we're adding something in. They are going to become automatic with their facts. They're not going to forget them because we're not doing this memorizing that leads to a lot of forgetting. And bonus, they're going to have these strategies that are super useful going forward. So to me, those are some of the really strong speaking points. I like to play a game and then just stop and pause for a minute and just say, did you see how hard it was for me to get you quiet? Did you see how much fun you were having? And then I just hold up a worksheet. I'm like, and how about this? Again, that emotional connection to the experience and the outcomes.
That is wonderful. Since you brought it up, let's talk about replacements for worksheets and time test.
Mm-hmm.
So you advocate for games, as you said, and for an activity-based approach. I think that what I want to try to do is get really specific so that if I'm a classroom teacher and I can't see a picture of that yet, can you help paint a picture? What might that look like?
I love that question because there's lots of good games in lots of places. But again, like I said earlier, this thinking really deeply about what game I'm choosing and for what do my students need to practice, and then being very intentional about game choice is really important. So, for example, if students are working on their 10 and some more facts, then you want to play a game where all the facts are 10 and some more facts. That's what they're working on. And then maybe you mix in some that aren't, or you play a game with that and then they sort cards and solve the 10 and some more, or there's lots of things they can do. They can play concentration where the fact is hidden and the answer is hidden and things like that. So you can be very focused. And then when you get to the strategies, you want to have a game that allows for students to say aloud their strategies. So I'm a big fan of like sentence frames, for example. So there's games that we have in our Math Fact Fluency book that are in other places that specifically work on a strategy. So, for example, if I'm working on the pretend to 10 strategy, I like to play the game Fixed Add-in War, which is the classic game of war, except there's an add-in in the middle and it's a 9 to start. And then each of the two players turns up a card. So, Mike, if you turn up a 7, then you're going to explain how you're going to use the pretend to 10 strategy to add it. And I turned up a 6. So I'm going to do this, then you can do it. So I turned up a 6. So I'm going to say, well, 10 and 6 is 16. So 9 and 6 is 1 less 15. I've just explained the pretend to 10 strategy. And then you get your turn.
And I'd say, well, 7 and 10, I know 7 and 10 is 17. So 7 and 9 has to be 1 less, and that's 16.
Yeah. So your total's higher than mine. You win those 2 cards, you put them in your deck, and we move on. So that's a way to just practice thinking through that strategy. Notice there's no time factor in that. You have a different card than I have. You have as much time, and we're doing think aloud. These are all high leverage practices. Then we get to the games where it's like, you might turn up a 6 and a 5 where you're not going to use the pretend to 10 strategy for that. You've got to think, oh, that doesn't really fit that strategy because neither one of those numbers is really close to 10. Oh, hey, it's near a double. I'm going to use my double. So you sequence these games if you start with one of those open-ended games, it might be too big of a jump because students aren't ready to choose between their strategies. They have to first be adept at using their strategies. And once they're adept at using them, then they're ready to play games where they get to choose among the strategies.
So you're making me think a couple of things, Jenny. One is it's not just that we're shifting to using games as a venue to practice to get to automaticity. You're actually saying that when we think about the games, we really need to think about what are the strategies that we're after for kids, and then make sure that the way that the game is structured, like when you were talking about the pretend to 10 with the fixed add-in, that's designed to elicit that strategy and have kids work on developing their language and their thinking around that particularly. So there's a level of intent around the game choice and the connection to the strategies that kids are thinking about. Am I understanding that right?
That's it. That's exactly right. That's exactly right. And a lot of intentionality so that they have that opportunity and no pressure, a low stress, think through the strategy. If they make a mistake, their peer or themselves usually correct it in the moment. And they get so much practice. And I mean, imagine going through half a deck of cards playing that game.
Yeah.
That's 26 facts. And then picture those 26 facts on a page of paper. And again, in the game, you've got the added benefit of think aloud, and then you're hearing what your peer has said.
You know, one of the things that strikes me is if I'm a teacher, I might be thinking like, this is awesome. I'm super excited about it. Holy mackerel, do I have to figure these games out myself? And I think the good news is There's a lot of work that's been done on this. I know you've done some. Do you have any recommendations for folks? There's, of course, curriculum, but do you have recommendations for resources that you think help a teacher think about this or help a teacher see some of the games that we're talking about?
Well, I'm going to start with my Math Fact Fluency book because that is where we go through each of these each of the foundational fact sets and the strategies, and for each one supply a game. And then from those games, they're easily adaptable to other settings. And some of the games are classic games. So there's a game, for example, called Square Deal. And the idea is that you're covering a game board and you're trying to make a square. So you get a 2x2 grid taken and you score a point or 5 points or whatever you want to score. Well, we have that game housed under the 10 and some more facts. So all the answers are like 19, 16, 15, and the students turn over a 10 card and another card. And if it's a 10 and a 5, they get to claim a 15 spot on the game board. Well, that game board can be easily adapted to any multiplication fact sets, any other addition. I like to do a square deal with 10 and some more, and then I like to do square deal with 9 and some more. There's my effort again to come back to either pretend to 10 or making 10, where they're like, oh, I just played 10 and some more. Now we're doing the same game, but it's 9 and some more. So I feel like there's a lot of games there. And there is a free companion website that has about half of the games ready to download in English and in Spanish.
Any chance you'd be willing to share it?
Yeah, absolutely. So you can just Google it. The Kentucky Center for Mathematics created it during COVID, actually, as a gift to the math community. And so if you type in Kentucky Center for Math or KCM, Math Fact Fluency companion website, it will pop up.
That's awesome. I want to ask you about one more thing before we close, because we've really talked about the replacement for worksheets, the replacements for timed test, but there is a piece of this where people think about, how do I know, right? How can I tell that kids have started to build this automaticity? And you make a pretty strong case for interviewing students to understand their thinking. I'm wondering if you could just talk again about the why behind it and a little bit about what it might look like.
So, first of all, time tests are definitely a mistake for many reasons. And one of the reasons, beyond the anxiety they cause, they're just very poor assessment tools. So, you can't see if the student is skip counting or not, for example, for multiplication facts. You can't see if they're counting by ones for the addition facts. You can't see that when they're doing the test. And you can't assume that they're working at a constant rate, that they're just solving one every, couple of seconds, which is the way those tests are designed, because they can spend a lot of time on one and less time on the other. So they're just not effective as an assessment tool. So if you flip that, let's say they're playing the game we were talking about earlier, and you just want to know, can they use the pretend to 10 strategy? That's your assessment question of the day. Well, you just wander around with a little checklist. Yes, they can. No, they can't. And so a checklist can get at the strategies, and a checklist can also get at the facts, like how well are they doing with their facts? So once they do some of those games that are more open-ended, you can just observe and listen to them and get a feel for that. If they're playing square deal with whatever fact, so what happens is you're like, I wonder how they're doing with their fours. We've really been working with their fours a lot. Well, you can play square deal or a number of other games where that day you're working on fours. The fixed add-in war can become fixed factor war, and you put a 4 in the middle. So adaptable games. And then you're just listening and watching. And if you're not comfortable with that approach, then they can be playing those games, and you can have students channeling through where you do a little mini interview. It only takes a few questions to get a feel for whether a student knows their facts, and you can really see who's automatic and who's still thinking. So, for example, a student who's working on their fours, if you give them 4 times 7, they might say 28. I call that automatic. Or they might do 4 times 7 and they pause and they're like 28. Then I'm like, how did you think about that? And they're like, well, I doubled and doubled again. Great. So I can mark off that they are using a strategy, but they're not automatic yet. So that to me is a check, not a star. And if I ask, how did you do it? And they say, well, I skip counted. Well, then I'm marking down the skip counted, because that means they need a strategy to help them move towards automaticity.
I think what strikes me about that too is when you understand where they're at on their journey to automaticity, you can actually do something about it, as opposed to just looking at the quantity that you might see on a time test. What's actionable about that? I'm not sure, but I think what you're suggesting really makes the case that I can do something with data that I observe or data that I hear in an interview or see in an interview.
Absolutely. I mean, this whole different positioning of the teacher as coaching the student towards their growth, helping them grow in their math proficiency, their math fluency. You see where they're at, and then you're monitoring that in order to move them forward instead of just marking them right or wrong on a time test. I think that's a great way to synthesize that.
Well, I have to say, it has been a pleasure talking with you. Thank you so much for joining us today.
Thank you so much. I'm, again, thrilled to be invited and always happy to talk about this topic.
This podcast is brought to you by the Math Learning Center and the Meyer Math Foundation, dedicated to inspiring and enabling individuals to discover and develop their mathematical confidence and ability.